Okay, we're going to start learning how to name aldehydes and ketones. In this next lesson, let's just review what makes an aldehyde and ketone. Alright, there we go. So remember that aldehydes and ketones contain this carbonyl functional group. Okay, this C double bonded to an O. Now sometimes we can distinguish between what's found in the aldehyde and what's found in the ketone. Okay, so when this carbonyl group, this C double bonded to an O, is bonded to a hydrogen, it is sometimes called a formal group. But either way, when that carbonyl group is bonded to a hydrogen, okay, that's what's found in aldehydes. We're going to use the suffix al, okay, at the end of the names of those molecules. And when that carbonyl carbon, so that carbon there, is bonded to two other carbons, okay, then we have a ketone, and our suffix is going to be O. Okay, we need to be able to distinguish them. Alright, let's skip on down to the naming of aldehydes and ketones. When it comes to aldehydes, okay, and ketones both, okay, the carbon that is in your functional group, that carbon of your carbonyl functional group, okay, is included in your parent chain. Right? Now, for aldehydes, because we have that hydrogen there, that carbon must be at the end of a carbon chain. And as a result, there's only ever one position for it. Okay? And therefore, you don't need to assign a locant to the carbonyl in an aldehyde. Now, sometimes we will see a formal group attached to a benzene ring, as we see over here. Okay? In this case, the benzene ring plus the formal group together form a root and a suffix, and this is called benzaldehyde. You remember how we saw a phenol before, with the benzene ring and the hydroxyl group? The same thing here. This is benzaldehyde. Okay, and again, the position of your formal group is assigned to carbon number 1. Okay. So let's do some examples. This is pretty straightforward. It's going to be very similar to the naming of the alcohols. Okay. So, alright. Example 1 here, again, let's identify the longest hydrocarbon chain that includes our functional group. Remember that rule. Regardless of whether we have something longer, like this, or larger, like this benzene ring, we have to include this functional group here, okay? And now there it is at the end. Now, normally we don't include that hydrogen there, right? But in this case we do. So here is my functional group. Okay, and that's a formal group, technically. We've got, and then let's just identify everything else. And here we have our substituent as a benzene ring that's directly attached to my parent chain. So this is a phenyl group. Now, again, when we number things, we always start on the side closest to our functional group. And this carbon, since it's an aldehyde, is always going to be carbon number 1. And when we put it in our name, we don't need to include that 1 in front of our suffix, because it's assumed that it's a carbon 1. Okay, so we have to start numbering at this side, obviously. Okay, so we're going to, our root is 5 carbons, so then it's going to be pent. We've got carbon-carbon single bonds, so we're going to use ane without the E. And then we've got an aldehyde. That's our functional group, an aldehyde. So our suffix is al. And that means this phenyl group is on carbon, not on carbon 4, but instead carbon 2. Apologize for that. That's on carbon 2. And you put it all together. 2-phenyl pentanal. Let's look at this next one. Again, here's my functional group over here. Okay, this time I haven't included the H. Okay, there's 1, 2, 3, 4, 5, 6. And if you can, include your your double bonds, because that will, or triple bonds, because that will lead to simpler side chains. So there's your longest hydrocarbon chain. And there's my functional group that's occurring at the end of that chain, so that also makes it a formal group, okay? Because we do not need to assign it a locant. Okay, we start numbering closest to that formal group to give it the lowest possible number. So that's 1, 2, 3, 4, 5. Oh, whoops. My bad, I missed the carbon. There's actually 6. 1, 2, 3, 4, 5, and 6. So our root, therefore, is hex. Then our suffix, we've got carbon double bond. Okay, and that's a carbon 4, so we're going to have 4-ene without the E. And then we have our functional group. That's going to be al. And again, we don't need a position for anything. Okay, we've got here and here. Those are both methyl groups. Okay, on carbons 2 and carbon 4. And so we're going to put this all together now. We're going to have 2,4-dimethyl. Right. X4-enal. And just a reminder that we always put the part of the suffix related to double, triple bonds or single bonds, okay, before the suffix portion related to our functional groups. Pretty straightforward. And let's look here. And when we pick our parent chain, first of all, there is our functional group. And you know what I need you to do here is actually delete that right there. There we go. Because that's going to change the naming. I apologize about that. Okay, so let's identify our longest parent chain. That includes our formal group, or a carbonyl group in this case. So we got 1, 2, 3, 4, 5, and we try to include that double bond, okay, because it leads for simpler, simpler substituents. Oh boy, we won't be able to name this either. Oh, okay, do me a favor, everybody. This is what we're going to do. We'll take that bromine. We're going to erase it as well. Okay, there. Now we can do this. We could. Alright. Start over again. I apologize. 1, 2, 3, 4, 5, and 6. Okay, there's my functional group. This is a carbonyl group. Okay, in the middle, it's not at the end. That's a carbonyl group. And what are the substituents we have? This is a methyl. And this here is a propyl group. Now again, when we do the numbering, we want to number to give our carbonyl, our functional group, the lowest number. So even though we have a double bond here, if we started numbering on this side, we could give it a lower number. This functional group takes precedence, i.e. we need to assign it the lower number. If there was a tie, then we would try to give the triple bond or double bonds a lower number. Okay, so we're going to start numbering from the left. 1, 2, 3, 4, 5, and 6. Which means in this case, our root is going to be hex. Okay, we've got carbon-carbon double bonds, which means in our suffix we're going to have 5-ene. Okay, without the E, because we only have one functional group. Okay, but then we also have our carbonyl. Now in this case, this molecule is going to be a ketone, because we have that carbonyl group in the middle of the chain. And in this case, we do need to include a position. Okay, and that's going to be on position 2. And our suffix, because it's a carbonyl group and that it's a ketone, the suffix is going to be -one. Okay, not 1, but -one. Okay, we're then now going to put it all together, listing our substituents in alphabetical order. So this is going to be 5-methyl, 3-propyl, X 5-ene-2-one. Okay. Let's do this next example. Again, longest hydrocarbon chain with your functional group and as many of your double and triple bonds as possible. Alright, we got 1, 2, 3, 4, 5, 6 carbons again. That's easy, it's hex again. Okay. Where's my functional group? Right here. That's C double bonded to an O. That's your carbonyl group. And then we have our 2 methyl groups right here. 1 and 2. Methyl groups. Okay, now we have triple bonds as well. Okay, and we have to assign numbering. And so again, we want to give this carbonyl group the lowest possible number, and that would only happen if we start numbering from this side. So 1, 2, 3, 4, 5, 6. If we numbered it from the left, it would have a locant of 4. Okay, so there's 1 through 6. We now have the position of everything, so let's look at the different parts of our suffix now. We've got carbon-carbon triple bonds. Alright, we have them on carbon 1 and 5, so it's going to be di-ine. And now that we have more than one triple bond, we need to add that A now at the end of our root. Okay, don't forget that. Then our functional group is going to be 3-one, because we have only one. And of course, we could have multiple, in which case we would add an E at the end of this if that was the case. And so now let's put it all together. And this is simply 4,4 dimethyl, okay, hexo 1,5-diine 3-one. Alright. Let's move on to drawing. Okay, so I'm only going to do a couple of these. I'm going to do the first one and the last one. Okay, so first things first, let's identify the parts of our suffix. Obviously, we're going to start at the end and observe. Look, what do we have? We have benzaldehyde. Okay, that means we have a benzene ring. Now, one of those carbons, doesn't matter, we have a formal group. There's our formal group. Right? I don't need to draw that H there, but you can. Alright, and that's going to be assigned carbon 1. And then you can number it any other way you want, it doesn't matter. We'll just go clockwise. Now we're going to add the parts of our prefix. 2,6-dinitro. That tells me I have 2 nitro groups on carbons 2 and 6. So they're my nitro groups. Let's do this last example here. You can try those on your own. Again, let's look at the suffix. So all this here from here, okay, this whole thing is your suffix. So let's look at the two parts. 3,4,6 trione. One. That tells me I've got a carbon-carbon or carbon-oxygen double bond. Okay, this is a ketone. Right? So this carbon occurs in the middle of your chain. If we look at this example, if I had al, okay, that tells me I have a formal group. Makes this an aldehyde. So I've got a ketone, but observe I have a 5,8-diene. That means I have carbon-carbon double bonds. And then that's my suffix, right? tells us about a functional group and any sort of carbon-carbon bonds. And then we have our root, deca. That means we have 10 carbons. And here we have our prefix, 2,2-dimethyl. Okay? That means we have 2 times 1 carbon chains. Let's draw that all together now. Let's draw a 10 carbon chain. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Let's just number this. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Now let's add my methyl groups. They're both on carbon 2. So here's 1. There's that 1 carbon, and then there's 2. Alright, now let's draw my double bonds between carbons starting at carbon 5. So there's 5, and then between starting at carbon 8. There we go. Now carbons 3, 4, and 6, we have my carbonyl group. So 1, there's the first one, there's the second. And of course this is not possible because this needs to be 7. There we go. We couldn't put the carbonyl group on carbon 6 because then this carbon would have 5 bonds, and that would not be possible. So let's change that to 7. Alright, so there we go. There's 2,2-dimethyl deca 5,8-diene 3,4,7 trione. That's that. Our next lesson is going to be on carboxylic acids and esters.